Hey, what's up guys? I am Bysisa. So today's episode is going to be on process simulation overview. So I'm going to use this problem sample question to overview a process simulation. So let me read the problem statement. A stream containing 18% ethane and 27% propane, which also contain 40% i-butane and 25% n-butane, at a temperature of 450 degrees Fahrenheit and a flow of 100 kg mole per hour. So the stream is to be compressed to a pressure at 50 psi and then cooled to a temperature of 82 degrees Fahrenheit. So the resulting vapour and liquid are to be separated at the two product stream. That means we are going to have vapour phase and liquid phase. So it's asked to find the fluid of the fluid and the composition in the vapour stream. So I'm going to use this question to overview a process simulation. So let's proceed to the Hysys simulation environment. So as usual, we'll now go to new. So you now select your component. So from the question I have, let's consult the question again. From the question I have ethane, propane, butane, and i-butane and n-butane. So let's select our component. So you go. So here in the search bar, you either type the name of the component, its chemical formula, or its synonym. So as you can see, here is our ethane, then you add it. Propane, you add. You have i-butane, you add it. You have n-butane, then you add. So the next step is you are going to select equation of state. So then we now proceed to upload package. So as usual, we are going to use pentagramine. So here is our pentagramine. A green color will be shown at the bottom of the interface, identifying that a particular equation of state has been selected as fixed conditions. So let's proceed to simulation environment. So let's select our stream. I have three different streams. I have four. So the first stream, I have ethane, second stream, I have propane, the third stream, I have i-butane, and the fourth stream I have n-butane. So the next thing you have to look for another unit. So the next unit is I'm trying to mix the four streams, so I have to introduce a mixer. So here we add our component, our elements, i-butane, then n-butane. So let's call here to be stream 1. So let's consult the question again. A stream containing 18% ethane and 27% propane, 40% i-butane and 25% n-butane. So let's insert our composition. For 18 I have 18%, that's 0.18. For propane I have let's check again, 27, 40, then 25. I have 27, that's 0.27. I have 0.40, 0.40. I have 0.25. Let's check so that I shouldn't make it any. And now go back to conditions. So the temperature for the stream, I have 150 degrees Fahrenheit and a flow rate of 100 kg per hour. Temperature of 150 is in Fahrenheit, so the unit is consistent. I have molar flow rate of 100 kg per hour. So after this, then we now go back to the question. Then the stream is to be compressed to a pressure of 50 psi. So I have to introduce a compressor. So this is our compressor. This is our compressor. So the stream is to be compressed at let's call it stream 2. Again, the stream is to be compressed at 50 psi. So I have 50 psi. Vapor phase is 1. So after this, then cool to 82 degrees Fahrenheit. So I have to look my cooler. This is our cooler. Let's call it stream 3. Let's call it C, stand for cool energy. Just to be cool at 82. To be cool at 82 degrees Fahrenheit. So 82. Then after cooling, then the next unit is before I look at to be separated the two product streams. So that means I have to introduce a separator. So double click, large, then you insert your material. So let's call this place to be before. So let's have a clear understanding of. So from the question, we are asked to the flow and composition in the vapour stream. So this table is for vapour. So we are asked to find the fluoride. So the fluoride is for vapour I have 220.5 pounds mole per hour. Then composition, in the case of composition, let's see, I have ethane to be 0.1636, I have propane to be 0.2455, i-butane to be 0.3636, then n-butane to be 0.2273. So in the case of liquid, even though we were not asked to find the composition for the liquid, but let's just have it for in case of having doubt. So in the case of liquid, the composition for ethane I have 0.0262, then for propane I have 0.1295. In the case of i-butane, its composition is 0.4544. In the case of n-butane, its composition is 0.393899. So in the case of today's class, we are going to I'm trying to show you how to overview a process simulation. So let's assume you are trying to see the temperature throughout the whole simulation. Maybe you are trying to see whether you make a mistake, or you are a little bit having a doubt, or you are not satisfied with what you have obtained at the output. So just go to flowsheet here, and in the case of 9, just click temperature. So automatically it will come up with the temperature at each unit or at each stream. So here initially I have 150 degrees Fahrenheit. Here I have 82. If you could recall from the question, I have a temperature of 150, then I have 82 when it's compressed, when it is cooled, then pressure to be 50 psi. So let's see, I have 150 degrees Fahrenheit, yeah, for the stream initially. Then when the stream is cooled to 82 degrees Fahrenheit, then the compressor is to be when the gas is when the stream was compressed, it says 50 psi. 50 psi. So here is temperature. I'm considering temperature. So here for the vapor I have 82, for the liquid I have 82. So in the case of you want to see the pressure, yeah. So at the first stream you have 189.1 psi. When the stream 1 is compressed, you have 50 psi. Also when it passes through the cooling unit, you have 70.67 psi. So at the vapor phase you have 70.67 psi. The same thing with liquid. So let's turn it to its name. So in the case of you want to see the whole result obtained from each stream, from each unit to the last from the individual units. So let's say you want to see ad hoc table. So let's say material, or let's say composition. So you see at ethane here, composition you have for stream 1. For ethane you have 0.1636, stream 2 the same thing, stream 3 the same thing. At therefore you have 0.1636. At liquid you have 0.0262. So let's say you want to see the composition for the whole or the energy stream for the whole simulation. Let's see. So the energy stream, that is the heat flow, you have negative 7.257 reservoir of 0.004. So let's say you want to see another for material stream. Let's add for material stream. So let's say I want to see the composition for the whole material stream. Material stream, then you select. So this is the properties, the vapour, temperature, pressure, molar flow rate for ethane. This is the corresponding data. For propane, the same thing. For i-butane up to the n-butane. So for stream 1 here, I have a vapour phase to be vapour fraction of 1.0 and a temperature of 150 from the question, the same thing. Then the pressure is from the question. Initially there was no any pressure given, so when we inserted our composition and the temperature, the pressure automatically it's been generated from the fixed equation of state, that is Penn-Robinson. So the molar flow rate I have, if I could recall, it was 100 kg/mole per hour. So in this unit the unit is not the same, so that means you are not to expect the value to be the same. I mean the value. So initially I was having 100 kg/mole per hour, but now it turns to 220.5 pounds mole per hour. So if you convert these pounds mole per hour to kg/mole per hour, you will have the same value. So the same thing, mass flow rate to be 1.104 times 10 raised above 4. For stream 2 the same thing. For stream 3 the same thing. Even the heat flow, the liquid volume flow. So up to the last unit, that is the separator, you have liquid and you have vapour and liquid. So this is the corresponding data for vapour and this is the corresponding data for liquid. So initially I was asked to find the flow rate and composition of the stream for the vapour. So the flow rate is that is the if you are counting from the bottom, 1 2 3 4, that is the fourth. 1 2 3 4. The flow rate is 220.5 pounds mole per hour. So if you convert it to other units, you will have the same or corresponding data. So in terms of liquid, none. Even the mass flow rate is 1.104. So this is it, how to solve to overview any process simulation in Hysys. So make sure to subscribe to the channel. Thank you for watching. See you in the next one.